welcome again to a new topic of Form 3. This is the continuation of our Form 3 topic series. Now here, we start with the topic termed as a circle. We have been coming across with round shapes like coins. All those shapes of that kind, they take the shape of a circle. So here we say, this is one of the most important and challenging topics to Form 3 students. So we need to know first for the learning objectives that at the end of this topic, you will need to know the meaning of the term circle, and you will have to know terms used in a circle. You will be able, we will have the ability to derive the formula for arc lengths of a circle and solving questions on the related concept of arc lengths. And then we'll have the ability to derive the formula for radian and solving questions on related concepts. We'll also have to check the applications of arc lengths and radian in real life situations. Also, we will have the ability to prove theorems used on circles. First of all, we'll have to know what is the meaning of the theorem. And finally, we'll be solving questions involving theorems of the circle as per the intention of Form 3 student. Now, starting with definition, we say a circle is the set of points which are at equal distance from the fixed point. We can simply make it like that. Is a set of points which are at equal distance from the fixed point. Or we say is a locus which moves such that it is always at constant distance from the fixed point. So let's consider the figure here. So you have the circle here. This is the fixed point. So P is the one we call it fixed point. So this is the fixed point of a circle. Fixed point of a circle. The constant distance from the fixed point to the circle is the one referred, we say this is the constant distance, abbreviated by S. So let's observe here. We say the fixed point is given the special name, which is referred as central point of a circle and is usually denoted by capital letter O. The constant distance from the central point to the circle, this one is referred as radius of a circle. We normally abbreviate it, denoting it by symbol, by a letter R. So the paths tracing throughout the entire circle, moving from A to C to A again, this path tracing out is referred as circumference of a circle. So it is always given by 2 pi r, in which pi is a constant number known to be 22/7, while r the constant distance from the central point to the circumference part of a circle. So it's called the radius. So let's continue now with the other terms used on the circle. Let's look at this. Okay, students. So another term, this time now we switch with the concept of terms used in a circle. So another term here we say there is a term referred as an arc. An arc is any part on the circumference of a circle. So when we have a circle, this any part on the circumference of the circle, a part AB and a part BC and a part CA, these ones are referred as arcs to the circle. So when you sum all arcs, we get the circumference of a circle, which is always given as 2 pi r. That's say when you take an arc AB plus an arc BC with an arc CA, give the circumference 2 pi r of a circle. So there are two types of arcs. One is referred as major arc and the other is minor arc. So when you have a circle like this, we have an arc AB, this one is the minor one, compared to this, which is the larger one. So let's abbreviate an arc, which is the minor arc, as X and the major arc as Y. So when you take the minor arc plus the major arc, you must be getting the circumference of the entire circle, which is this. So very important with these types of arcs. Now there is a line segment which touches two and only two parts on the circumference of a circle. It is referred as a chord. So we say a line segment which touches exactly two parts on the circumference of a circle. So given a circle like this, with central point at O, a line AB is a chord, a line CD is a chord, a line EF is a chord. So we say A chord which is passing at the center of a circle is referred as diameter, which is important. A chord passing through the central point of a circle referred as diameter. So with reference to this geometry here, the length CD is a chord with reference to this circle here. CD is a chord. So what do we deduce now? We found with the chord CD, it is the length radius and the radius with the entire diameter. Therefore, diameter means radius plus radius, in which we conclude that diameter measures twice radius. Diameter measures twice radius. Now, there is another term. This one is referred as symmetry line of a circle. It is an imaginary line which divides the circle into two equal and identical parts. So when you have a circle here with the central point, so this is a symmetry line in which we have two equal and identical parts of a circle. These parts are referred as the semicircles. So let's continue with the definition. Let's look the next part. Okay, so other terms here. First of all, we say with the meaning of symmetry line of a circle, it must be concluded that diameter is also an example of symmetry line of a circle, since it also divides the circle at two equal and congruent parts. So we have another term. This one is referred as a semicircle. A semicircle is a half in area of a circle. There are two congruent semicircles, in which when you have a semicircle, there must be a diameter making two congruent half in area of a circles. So when you have a figure here, the region marked P here, and the region unmarked, these are two congruent semicircles. So when we sum all two semicircles, you must be getting total area of a circle. So we have another term here. This is referred as a segment. A segment, a region on a circle, in which it is bounded by a chord. So looking at the line AB is a chord and bounded by an arc. So we have a line AB and an arc. So this region is referred as a segment. And this one is also a segment since there is an arc here, major arc, and also the same chord. So we simply say we have minor segment and major segment. In the case of semicircles, the two segments are congruent. But here in normal situations, we have minor and major segment, in which summing the minor segment and major, you must be getting total area of a circle, which is pi r square. So this is one of the most important terms used in a circle. We have another term. This one is referred as a secant. It is a chord which cuts the circle at one or both sides of a circle. So you see a chord xn extended to both sides cutting the circle, extended to z and e, is now a secant. In the same way, a chord PC extended to one side to V, it becomes a secant. In the same way, a chord TS extended to R is also a secant. So this is always the concept of seconds. So we have the term a sector. A small part or the area on a circle bounded by two radii. So looking at this circle here, there are two radius. So this area bounded by two radii and an arc. So bounded by two radii and an arc. This one is, so the shaded part is a sector. Bounded by two radii and an arc. This is the one referred as a sector. So let's switch with the other terms. Let's go. Okay, students. So the other term here, we have another term. This is referred as a quadrant. A quadrant, these are four equal parts. We can call it four equal sectors. We can make it in other words because they are always bounded due to the intersection of two diameters. The next topic of Form 4 series of topics. We are now switching with the topic of linear programming. This one as the topic itself, linear programming. So at the end of this topic, we need to have the concept of the historical background of the topic.